Built my home on hollow ground. Too proud to grow from my roots.
Hi, this is Craig Smith with a new podcast about artificial intelligence. I'll be talking to Jack Clark, author of the popular Import AI newsletter, about what he's learned during the previous week and why it's significant. Jack is a veteran of the British technology journal The Register and of Bloomberg News. He now works on policy and communications for OpenAI, the nonprofit artificial intelligence research company founded by Elon Musk. So think of this podcast as a review of what's happening in the world of AI, curated by one of its keenest observers.
Find a bridge between you. Cross it to find your synthetic light.
I wanted to start by talking about the bottom of the newsletter this week, in which you talk about what was said at the World Economic Forum in Davos. And the thing that made a lot of headlines and certainly jumped out at me was Google CEO Sundar Pichai's comment that the rise of AI is more important than the discovery of electricity or even fire. And you see a lot of statements like that. It surprised me seeing that come from Pichai, although I don't follow him closely. Is that overstating it in your view?
It is not overstating it. And I think it's pretty commendable that he's talking about this head on, because a lot of executives have been trying to say that this technology has the same attributes as previous disruptive technologies, like the advent of the smartphone. This is of a fundamentally different nature. And though when we hear people talk about electricity and fire, we think that's incredibly overblown, I believe that if you think of how AI is going to play out over the next not just few years, but few decades, we're going to look back on it with something equivalent to that. From a historical perspective, it will suddenly look like you built computers, and very soon after, the computers gained human-like capabilities. And soon after that, as we've seen with things like AlphaGo, that the computers quickly surpassed human experience. And that's very unusual and I think significant.
Yeah, no, I agree. I guess I'm a bit of a skeptic in the timeline. I mean, I can see superintelligence and the intelligence explosion happening at some point in human history. I just am not optimistic it's this century. But we will.
Well, it does not need to be superintelligent. I'm going to push back on that point with you now, which is that, sure, superintelligence, yes, that's going to be obviously a big deal if it happens. But we don't need for that to happen for this to be huge. I mean, think about exactly how much the world was changed by the advent of the database or the spreadsheet. You know, the ability to just have computers organize rote textual information is one of the forces that led to globalization and the information revolution. So now we have capabilities that let computers access basic human senses like an approximation of vision, an approximation of hearing, and they're going to live in a world which is actually built for humans to see and hear things. So just try and imagine about exactly how much information is becoming available right now to computers, and then think about what happened over the last 30 years with spreadsheets or databases. And I'd say to you that we don't need this stuff to be super intelligent for it to change the world far more than the digital revolution so far has to date. And that to me is kind of mind-boggling.
Yeah, and that much I certainly agree with. He talked about the need for global multilateral frameworks, and then Theresa May put her country's flag in the ground as a leader in developing the ethics of AI. Is that over-optimistic to think that we'll be able to come up with a multilateral framework that countries will adhere to, given how unsuccessful we've been with nuclear energy technology or nuclear weapons technology?
You and I are having this conversation, and neither of us can point to a place on the earth which has had a nuclear weapon used in anger since the World War II. again, I'm going to say to you, we built institutions that worked here because we aren't talking about a tragedy after Hiroshima and Nagasaki. There is huge proof that the international governance system that we built around nuclear weapons works. It has its problems. You and I are speaking in 2018 at a time when I think the clock to midnight on how far away we are from nuclear annihilation has ticked up to 2 minutes to midnight, which is the closest it's been in a while. But nonetheless, we persist. So no, I don't think it's over-optimistic. I do think it is optimistic. And it's optimistic especially as, you know, someone coming from the UK, which is kind of unmooring itself from Europe and therefore from power blocks. I do think it's realistic to think that we're going to see countries collaborate on various AI standards. And I think it's more than likely that you're going to see norms develop in the international community around AI and how it intersects with the military. Other than a few bad actors, we rarely use things like chemical weapons and cluster bombs these days, thanks to international norms. And yes, there are exceptions, but we know that we can do this stuff. It's just immensely difficult. But that doesn't mean we should kind of shy away from the problem.
Yeah, I guess the thing that's been said about AI is, unlike a cluster bomb, it's much more difficult to detect when it's being used. As far as Theresa May's claim that the UK will be a leader in AI, from my point of view, I mean, I spent much of my career in China. I see China as the clear leader going forward simply because they benefit from a centrally commanded economy and they have a huge state sector that doesn't worry about cost. They've got the largest population and are spinning out the most engineers. Do you think that countries like the UK have a chance to play a leadership role? And do you think that countries like China will engage in the kind of frameworks that the West is going to want to control this stuff?
Okay, so you're handing me a very complicated question there, and I'm going to split it up into a couple of things. Do I think countries like the UK can have a role here? I'm skeptical. And I'm skeptical because we know that AI requires you to be at sort of the pinnacle of scientific and technological development from a national perspective. So though the UK has some AI advantages, I'd argue a huge amount of that is because of investment into the UK from American companies, you know, Facebook and Google and Microsoft. And the startup ecosystem in the UK is somewhat contingent on that. So Prime Minister May is giving the impression that this is entirely domestically developed. But if you look at the enabling factors, it actually comes from somewhere else with a kind of larger amount of money swilling around in it and a proportionally larger scientific and technological culture. Now, do I think that larger countries like the US or China or India or Russia, even by virtue of some of its specific investments, can have a role in international AI? Yes, that seems likely. And I think that we see the emergence of what one could term power blocks here. Now to your question of norms, you know, will these various power blocks respect the norms which the majority tries to set? Mostly no. Mostly people are going to do what they've always done, which is try to grow their own economies and compete in the sort of international game of geopolitical brinksmanship. But, and here's the difference, and you alluded to this earlier, AI has the potential for great harm. And so there are incentives here for collaboration around certain norms relating to how one wields and uses AI, which even if you have radically different ideological attitudes towards how you see yourself competing on the global stage, you have a pretty big incentive to want to be able to have certain confidences about your competitors or opponents and how they'll use this powerful technology. So I do think that countries like China, as you mentioned, will have an incentive to conform to some norms. I do think that those norms are going to be relatively few in number, though.
Yeah. And we talked about this before, the question of whether or not China is publishing everything that they do in open forums. My guess is that there's a lot, and I think you agreed that there's a lot going on in China that no one sees. And that's certainly some concern.
Something else you write about in the newsletter is a student in Florida who used computer vision and deep learning to create a live overview of a popular multiplayer online video game, League of Legends.
What struck me about that is the relative ease and low expense, both in dollars and computational time, with which this guy managed to come up with a solution. It also highlighted to me how much data there is out there to play with if you know how to scrape it, because he was using just videos of gameplay. Beyond that, I'm not sure I can see the usefulness of what he's done except for that world of gaming. But that struck me, that the student in Florida could, with very little money and with publicly available data sets, come up with a solution. I would guess we're going to start seeing more and more of that.
Yes, and I think you've hit on a really interesting point, which is, why is this interesting? Well, it's not interesting that they were able to build a cool doohickey for an esport, for a computer game that you and most people will not have heard of. What is cool is that this doohickey allows them to access information about the game, which the company could expose via the application programming interface of the game to developers, but have chosen not to. And so in a sense, the significance of this is they were simply able to point this powerful technology at a bunch of data that they were able to scrape from the game. And in doing so, the deep learning algorithms essentially improvise the underlying API, which the company didn't want the person to have access to. So when we think about what this means, it really calls into question a lot of stuff about how proprietary software works. Because the assumption with proprietary software is, I can sell you some software because you're going to get some value from it, and you're not going to be able to clone the software I sell you purely from looking at the inputs and outputs of the system. And what this gives us a flavor of is that with lots of AI technologies, all I need to know is the inputs and outputs, and I can improvise the rest. And that calls into question a lot of how we think of IP protection and IP-based businesses working in the modern era.
Yeah, you've got this student in Florida that's able to come up with this pretty interesting solution based on open source software and publicly available data. And then you have these powerful tools like Detectron that people like Facebook are making publicly available. Is the day coming when the sort of democratization of AI, when it escapes the big, heavily funded labs and becomes a garage production thing, you know, where people are doing things out of their basements? And I mean doing significant things out of their basements.
No, sadly. And I can explain why, or I don't know if my response is just going to depress you so much you want to stop this endeavor. Would you like me to explain why I think that's not the case?
I would be fascinated, yeah.
So what you see with these kinds of things is what I term a computational dividend from these large companies. So they've spent a huge amount of money on electricity bills to develop some system that has a capability. In this case, a research platform that can let me draw bounding boxes around the world. So fine, that represents the basic sort of commoditizing effect of technology R&D. And it means that people in garages around the world are now going to be able to access this basic sense, right? In the same way that it's a commodity currently to be able to point a webcam at the world and have it offer a label as to what it thinks the most prominent thing in the image is. with stuff like Detectron or stuff like the League of Legends thing we were speaking about, you can point your camera at something specific and have it produce a load of information about that, or you can point it at a specific domain and get it to tell you something useful. But none of those things really represent the cutting edge. The cutting edge is going to exist on far larger computers than any startup can possibly hope to wield or any person in a garage. It's going to require research techniques which have not yet appeared in research papers, and the difference in capability is going to be profound. You know, in AI now, every 6 months the world changes, and it used to be every few years the world changes, and before that it used to be every decade the world changes. The technological epochs are multiplying and the intervals between them are reducing. So the kind of competitive moats that people like Facebook and others have is getting deeper over time because they're able to wield larger and larger models. And I'll give you a very sort of tangible example of this. I, as a startup, can have Detectron. I, as a startup, can have a residual network or a highway network or some kind of advanced deep neural network system. I can even have the data. It's still going to take me a period of time to train a model based off of my own data to do something useful. And the training time is going to be conditioned on the amount of computers I can access. And I don't know how large your garage is, but it's definitely not as big as a football field, I'd wager. Whereas Facebook has a football field worth of computers. And what that means is that when Facebook wants to do something involving R&D, it can do it far faster than anyone in the garage. So Facebook's ability to empirically experiment and discover new AI techniques is proportional to the amount of computers Facebook has. It's very hard to see a world in which startups can really easily compete with these AI giants because they simply don't have a large enough computer to be able to experiment as rapidly as them, despite having benefits of the computational dividends from the companies.
Well, maybe it's the computational dividends, though, that will finance or make possible smaller applications that the big guys aren't interested in pursuing or aren't spending time thinking about.
You wrote about DroneNet, a joint project between universities in Switzerland and Spain to train drones to fly along city streets. They used publicly available data from self-driving cars and created their own data set with bicycles.
That, to me, was fascinating, and it was, again, something that was created without huge investment and based on open source technology with, I think they were using Parrot drone, which is a cheap consumer drone. Isn't the computational dividend there in these applications that are going to start happening on a more localized level?
Yes, in the sense that you're going to see some innovation at the edges. Sure, absolutely. The data set which they trained that drone from, there were two parts to it. One was a bicycle. So they didn't have a good data set of collisions. So they got a bicycle, strapped a GoPro or something to it, and just simply pedaled with intent towards obstacles and tried to simulate collisions. I was quite glad to read in the paper that they didn't actually just generate tens of thousands of collisions. I would have felt very sorry for the researcher who had to do that. But what they did is they kind of accelerated towards it, deliberately slows down, and then labeled that as something that the drone should avoid. So sure, they generated some of their own data, but you'll notice that the really strategic data, which is the actual car driving data, the bit which tells the drones how to steer, how to follow the road, that comes from Udacity. That comes from a data set generated by the Udacity online education course for self-driving cars. So the Udacity online education course for self-driving cars is a course run by Sebastian Frun, who helped design Google's self-driving car. Udacity itself is funded by tens of millions of dollars of venture capital. And Sebastian Frun knew how to create that data set after spending 4 or 5 years working in secret at Google on its self-driving car project. So none of that suggests to me that Google is any less ahead as a consequence of this. In fact, it suggests the opposite. But what we're seeing here is kind of late-stage research projects made possible by investments made many years ago by companies which are somewhat opaque to us and whose capabilities aren't super obvious. Yes, it creates a capability that's interesting, like drones that can do some useful stuff, but imagine how much better that drone would be if it was trained off of Google's giant internal self-driving car data set. I think that can give you an idea here for how, say, Waymo, at the drop of a hat now, Waymo knows it can train a far more capable drone navigation model than that which appeared in this paper, because rather than having 70,000 images, it'll have 700 million. And it's really, I just want to push on this point. I am struggling to see evidence of the possibility of effective competition in the AI ecosystem. No one has shown me evidence to convince me that startups have an easy life here. And in fact, all of the evidence I see says the opposite. It says that startups are either using the dividends, so the lag investment of big companies, or they are competing in territories where we know the big companies have innate advantages and could simply exercise those advantages and run over the startups.
Are cases like Deep League and DroneNet more examples of bright young engineers who will eventually go to work for Google, Facebook, Uber, Amazon, or one of the big guys?
Yes, as far as I can work out, this shows us that it's easy to contribute to AI. It's easy to develop AI in the open using tools which are being given away to you by these larger companies. But I haven't seen an AI startup emerge which can truly show a capability that exists in excess of anything you see from either top-tier academic research institutions or far more frequently, the large companies. To me, AI is going to challenge a lot of our notions of antitrust and a lot of our notions of how competition works in technology, because the moats seem to sort of grow deeper over time, even though you're able to release a huge amount of it as open source or in the open via research papers. It's very paradoxical, and it's going to mean that if you're a regulator, all of the symptoms are of a kind of healthy market. You have some startups, you have lots of open innovation, you have lots of sharing, but then when you prod at the fundamentals, look at where the money's coming from, who has the strategic asset needed to do business, like data or compute, or who has the talent, you find that it's actually just for very large companies which have a kind of vice-like grip on the fundamentals of what we think of as the ingredient to competition.
Yeah. And the stress is on companies, not on nation states.
We can't view this in terms of nation states yet because we don't really have the manifestation of coherent nation state research agendas yet. When you look at organizations and countries in China, you see a very tight loop between government and the private sector and the public sector. None of it is what I'd quite call yet Chinese research. It's more just what happens if you're trying to catch up with people like Google and Microsoft and Amazon is you play every card you have. So in the case of China, that's using huge amounts of data, huge amounts of built-in commercial assets like your companies, and also the ability of government and funding to make things move a bit quicker and accelerate stuff. There is no research paper that I'd say has a particular Chinese flavor yet, nor would I say that there's research I read where I say, oh, well, that feels like a very Belgium-like AI paper or German AI paper. I don't think we're quite there yet. These power blocks are going to manifest, but they'll manifest under the purview of the implementation of national AI research agendas. And really the only country even doing national AI research is China, and it only just initiated that. So we need to wait about 3 or 4 years before we can see the sort of fruits of those initial investments and intent on its part.
That brings us to Cyclab, which I really did get excited about. To me, that was the beginning of testing an AI against human intelligence in psychometrics. Can you talk a little bit about that?
Yes. So Cyclab is a deep learning and reinforcement learning testing suite from DeepMind. And what Cyclab does is it makes it possible for us to test and evaluate reinforcement learning algorithms for not just their performance, but how well they do on human psychological tests. So what this means is you can now test an AI algorithm on a cognitive science test, and you can also have a human go and run the same test, and you can compare their performance. And the most interesting thing to me is that Cyclab let the scientists at DeepMind surface some pretty meaningful data points regarding the relative performance and drawbacks of their algorithms. In one case, they performed a test where they asked the reinforcement learning algorithm they were testing, which was from a system that they call Unreal, which is one of their best performing and most sort of highly tuned systems. They asked it to perform a very basic test in cognitive science, which is to do with looking at different sets of kind of concentric circles. It's called the shattered glass problem, and working out which one has the sort of largest amount of concentricity in it. What they discovered is that the Unreal agents performed very, very badly relative to humans, and they were able to hypothesize that perhaps it performed badly because the way that the gaze or the vision system of these Unreal agents works is rather too different to how human vision works. So what they ended up doing is implementing a vision system which was heavily based on what we call foveal vision, which is how in the center of your eyeball, Craig, you have more receptors relative to the periphery. And this is what allows you to focus on objects that are close and to have higher resolution on things at the center of your vision. With a traditional convolutional neural network, the receptive field is going to be uniform across all of it. What they did is that they bunched up the receptive field of a neural network in the same way you do it with a human eyeball, foveal vision. And what they found is that not only were they able to create an agent that started to pass these tests with closer to human-like performance, but they were able to take that very same agent and place it in a reinforcement learning environment called laser tag, which was not tested anywhere else in this testing suite and is actually much more like you having to play a virtual game of paintball with your friends or laser tag. And they found that suddenly they'd created Unreal agents which were able to excel in this environment at a level of performance they really hadn't been able to achieve before. So what that tells you is that by doing this sort of psychological or cognitive neuroscience testing on their agents, they were able to actually find a drawback, fix the drawback, pass the test, and then take that agent out of the standard testing regime of Cyclab and still show good performance and in some cases exceptional performance on wholly new tasks it hadn't been tested on before. And that to me is just so exciting because it gives us a whole new way of thinking about how we can stress test these algorithms and how scientists can have another kind of tool in their experimentation kit to help them diagnose things about it.
Yeah, I was also fascinated by that foveal vision fix, if you want to call it that. And one of the things that I found interesting is where the gaps in the abilities of both the Unreal agent and the human match in that glass pattern test, where one dot is white and the other is black. Neither the human nor the AI agent could recognize the pattern. To me, that was fascinating. So there's something in the cognitive processing of that breaks down in both the human and the artificial agent. And the other thing that really struck me in the analysis in their paper, they talked about how the convolutional neural networks can process features in parallel on a GPU, but humans are primarily restricted to serial processing of visual data. And then they asked rhetorically why evolution didn't give humans such an ability, as you would presume that it's an advantage. But then they noted that the subjective experience of serial processing feels very much like the essence of thought, because you think in a sequential stream, which to me, that was fascinating, that you can start to identify features in human mental processing that are different from an artificial agent's processing that might explain some of our subjective experience. I don't know if you picked up on that, but that was fascinating to me.
Yeah, I mean, I think if AI continues to develop, we are going to learn very surprising things about our own biases and proclivities, because we're going to be able to hold up a cognitive system to a mirror. You know, when you look in the mirror in the morning or the evening, you see yourself, but you don't really have a way of seeing a mirror to how your brain thinks you should act in the world, because there's no mirror that can simulate another person. We just look at other people and model ourselves on them. And what these AI systems and Cyclab shows us is, as we get more creative and advanced agents, perhaps we can have something that looks like a cognitive mirror, where we can look at a different way of thinking and dealing with the same task, and in doing so, learn more about ourselves. And that to me is so exciting.
Well, that's it for this week's podcast. Thanks again, Jack, for making the time. For those of you who want to go into greater depth about the things we talked about today, you can find a transcript of this show in the program notes, along with a link to Jack's newsletter. I encourage you to subscribe. Let us know whether you find the podcast interesting or useful, and whether you have any suggestions about how we can improve. The singularity may not be near, but AI is about to change your world. Pay attention.
No, I can't get close till I buy my time.